The image is iconic. Galileo Galilei, the rebellious astronomer and physicist standing atop the Leaning Tower of Pisa, poised to release two spheres of differing weights. The anticipated outcome, dictated by centuries of Aristotelian thought, was clear. The heavier sphere would plummet to the earth with greater speed. Yet, the popular narrative insists the two spheres struck the ground simultaneously, shattering the long-held belief and ushering in a new era of scientific inquiry. This dramatic demonstration, though potentially more legend than literal event, serves as a potent symbol of Galileo's revolutionary contributions to our understanding of motion and gravity, forever linking his name to the challenge of established dogma. For centuries prior to Galileo, the teachings of Aristotle held sway over the scientific understanding of the natural world. One of his tenets concerned falling objects, asserting that their speed of descent was directly proportional to their mass. This seemed intuitively correct. A stone falls faster than a feather, a cannonball faster than a pebble. This observation, however, failed to account for the significant influence of air resistance. Galileo, through a combination of ingenious thought experiments and meticulously conducted physical experiments, began to question this widely accepted principle. The story of the Leaning Tower experiment, while lacking definitive contemporary documentation, encapsulates the essence of Galileo's challenge to Aristotelian physics. By purportedly dropping objects of different masses from a significant height, he aimed to demonstrate that, in the absence of air resistance, all objects accelerate towards the Earth at the same rate, regardless of their weight. The simultaneous impact of the spheres would have been a powerful visual refutation of Aristotle's claim, suggesting that gravity imparts the same acceleration to all objects. However, the historical reality of this grand public demonstration remains a subject of scholarly debate. No direct account from Galileo himself or his immediate contemporaries explicitly details such an event at the Leaning Tower. Some historians suggest that the story may have been popularized later, perhaps by Galileo's biographer Vincenzo Viviani. It is plausible that Galileo employed thought experiments to argue against Aristotle, or conducted smaller, less public demonstrations to illustrate his point. Regardless of the veracity of the Leaning Tower narrative, Galileo's actual scientific work on falling bodies was undeniably groundbreaking. Through clever experimentation, particularly using inclined planes to slow down the rate of descent and allow for more precise measurements, he systematically investigated the motion of falling objects. These experiments led him to formulate the law of falling bodies, which states that the distance an object falls is proportional to the square of the time elapsed, d propto t squared. More importantly, he concluded that the acceleration due to gravity is constant for all objects near the Earth's surface, a radical departure from Aristotelian thought. Galileo's insights into the nature of falling bodies laid crucial foundations for the development of classical mechanics by Isaac Newton. Newton's laws of motion and his law of universal gravitation built upon Galileo's work, formalizing the concept of a constant gravitational acceleration and extending it to celestial bodies. Furthermore, Galileo's emphasis on empirical observation and experimentation as the primary means of understanding the natural world marked a significant shift in scientific methodology, paving the way for the scientific revolution. In conclusion, while the dramatic image of Galileo's experiment at the Leaning Tower of Pisa may be more myth than precise historical record, its enduring power lies in its symbolic representation of a pivotal moment in the history of science. It embodies Galileo's courageous challenge to established authority, his commitment to empirical investigation, and his profound contribution to our understanding of gravity and motion. Whether or not he truly ascended the famous tower, Galileo's intellectual ascent revolutionized physics, forever changing the way we perceive the fundamental forces that govern our universe.